We go with the next section. I did forget to mention something. If you have to identify an unknown atom, I don't know if you remember what to do. So let's unknown atom. So if you have to identify an unknown atom, is going to count the number of electrons because they are easily visible. And remember, the number of electrons is equal to the ape number. So for example, if we have, I don't know, beryllium, let's say, beryllium has a element key that looks like this, and 9.01 rounds to 9, just saying. And then you had an atom that looked like this. And you really can't tell what's going on here in the nucleus as far as you're not sure, is that all they have? So go to the energy levels in the electron cloud and count the electrons. So I see, number 2 on the first shell, 8 and 8, 288, super electron highway. 2, 3, 4, 4 electrons means ape number 4. So that must be beryllium. It's an atom of beryllium. Okay, guys? Just making sure. All right, so here's one thing that we did not get to cover this semester. We kind of ran out of time. And there is a formula chart on the back of your periodic table. And on the formula chart, it has 4 formulas. And one of those formulas is density. So we're going to do a quick density. Just the idea to... Density is a ratio between mass and volume. Meaning the denser things have atoms that are tightly packed, whereas less dense things have atoms that are less tightly packed. And that's all this means, okay? So the formula for density is mass over volume. Or you could say density is equal to mass divided by volume, like that. Or density is equal to mass divided by volume. So you need 2 things. You need mass and volume. So first, get the mass. And divide by volume. So for example, if I have something that has a mass of 100, mass is 100 grams, okay, and volume is 25 milliliters. So I'm going to take density to mass, which is 100 grams, over volume, which in this instance is 25 milliliters. And I'm going to take my calculator and I'm going to divide it. 100 divided by 25. And I'm going to come up with the answer 4. And I'm just now going to put my units, my mass unit over my volume unit, and that's my answer. So it's not hard. You have the on your On the back of your periodic table is the formula chart for science, so that formula is there. Sometimes they will substitute centimeters cubed for milliliters because they're the same unit. Don't let that throw you. Do the same thing. Mass by. So another example, let's do an example with meters cubed. Doesn't mean anything different. Like I said, the mass 53 grams and the volume is equal to 6 centimeters cubed. So let's see, you get my calculator, and you will need one as well. You can use your computer calculator. So we have 53 divided by 6, that equals 8.833333. So let's say they said round to the nearest tenth. That would be the number after the decimal. So I would say 8.8 grams for my mass over, because we had to divide, right? Centimeters cubed. If you have to put any number into a griddable, this would be a good example. The decimal goes where the decimal is on the griddable. You only have to fill in the numbers that are required. So you would only have to put in your griddable, let's say this is your griddable, and here's your decimal point. So you would enter 8, and that's all you have to put. If they asked for the number to the nearest hundredth, and you can see it is 0.8.83, they asked for the number to the nearest hundredth, I would have had to add my 3. This is the tenths, that's the hundredths spot. Okay? Alrighty then, moving right along. Alright, so on the universe portion of this test, obviously you're going to have to know the following. So let's look at what you need to know. First of all, let's start with our sun. And so we are in the Milky Way galaxy. And our galaxy is a spiral shaped. Our solar system is part of this galaxy, right? And we are located near the edge of a disc-shaped galaxy. So meaning if you looked at our galaxy from a side view as a disk, something like this, of course it would have its swirling arms like that, but it's kind of disc-shaped from the side view. Remember we had did top-down view and side view? We are somewhere out here on the edge of this disc-shaped galaxy. The sun itself, if we think about our sun, it is a main sequence star, right? It's living. It is yellow in color. It is medium in size. And it's the one with the spectral class G. Remember those letters that correspond with color and temperature on the HR diagram? That's the spectral class. G is the one it falls into. You need to know that a nebula is an area of gases, dust, and debris bound together by gravity, and this is the birthplace of stars. Remember, if you looked at the star life cycle, these large nebula that result from the supernova explosions, so that's the end of a star's life cycle, but all of this gases and debris and things that are in these gas clouds can come together and form new stars. So this is also where stars are born. I'm going to have to print out some pictures for part 4, but before we get to that, so let's talk about, we'll go back to reading the electromagnetic spectrum and for a minute, but let's go to what we're currently working on, rotation and revolution. Remember, rotation occurs on an axis. It gives us day and night. So in other words, the side that is facing the sun experiences daytime. The side of our planet that is not facing the sun experiences nighttime. So if we were to draw this, here's the light rays from the sun. Here's our planet. And you can see, obviously, that there is one side. We'll have to divide it in two. Oops, my stuff's going down. So the side, this side of the ball is facing the sun, whereas this side is in darkness. So this side will have daylight, and the opposite side will have nighttime. The side facing the sun has day and night, day, and the other side night. So this line here is the day-night line. This side has day. This side, not facing the sun, has night. Okay, we rotate counterclockwise. We rotate into and out of daylight, into day, out of day, and so on and so forth, right? One rotation is 24 hours or a day. Okay? So the side facing the sun is going to have daylight. Hope there's not any questions on that. To revolve, remember, meant to move around another object in space. So revolution. Had O for orbit. And it's one object moves around another object. Whereas this here gives us day and night. Rotation is spinning, right? Spinning on an axis. All right, and this is following an orbit. So our orbit takes 1 year or 365 0.25 days to be exact. This motion gives us our year, right? It gives us our year. And if we were to look at that, remember everything is moving counterclockwise. So if this is my sun here, and here's Earth, it would move all the way around the sun in an elliptical orbit, and that motion from this point all the way back is going to take me 365.25 days, basically. And that gives us a year. All right. Let us do one more thing. Let's briefly review our seasons. So for seasons, you need your diagrams, but real quick, the reason Earth experiences seasons is the tilt on its axis. So if the Earth would not tilt on its axis, it would not have seasons, okay? So Earth's axial tilt, remember it's tilted 23.5 degrees off center, is the reason for the seasons. And that's it. So I need you to make sure you have your seasons diagram readily available. I'm not going to redraw it here. I'll just add to the post. So I'm not going to review it because we just did it. So let's go ahead and do one more thing. Let's talk about, let's not do another video. We're just going to move forward with this one. We're going to talk about the HR diagram. Remember, it classifies stars based on two factors. And those two factors were temperature and the other factor was brightness, how bright these are. Okay, that's what it seeks to do. We're looking at the diagram. It's kind of strange for the temperature part. It goes from coolest stars on this side to their hottest stars. On this side. So temperature runs opposite we are accustomed to. So once again, these side is the coolest stars, and going this way do we get to the hottest stars. Okay? As far as brightness goes the y-axis, this is our brightness right here. It increases from bottom to top. So down here towards the bottom of the diagram are the dimmest stars. And up here at the top are the brightest stars. In that direction, right? Another word for brightness. So we had three words that could be used to indicate brightness. One is brightness, one was magnitude, and one was luminosity. All mean the same thing. So that's how you read it. Dimmest to brightest, coolest. We'll have to look at stars. Remember to find, to look very careful and compare them very before you make a choice. Also, what's important to know is that the sizes. So a supergiant star is the largest. And then it goes to giant, to main sequence, and then to dwarf, white dwarf. And they are the smallest. So it indicates size. It also kind of indicates where stars are in their life cycle, because supergiant giants are dying stars, dwarfs are almost totally dead. So there you go. Let's see. Okay, color. Remember, there is a color component here. The red stars were the coldest stars, and the blue stars were the warmest stars. So some you have this, you were able to color code. Red to orange. Let's see, where's orange? Right, red to orange stars. Red were the coolest. And then you had yellow. And then there was an area with white stars. And then there was blue and blue-white. So it's a darker blue. Blue stars. And blue-white stars, which I just do with a lighter blue. White stars were the hottest stars. So color corresponded to temperature. And they corresponded to temperature as well. Those letters at the top are referred to as the spectral classes. I know our star is a G star. So let's put those letters up there with it. So these hottest stars were class O, and white stars were A, yellow stars are G, white yellow were F, so yellow stars G, that's ours. K or orange and M is, and these letters, these are spectral class. Spectral class. I'm going to put corresponding temperature. Okay, so spectral class letters correspond to temperature. We already said earlier our star is a G star, yellow. Main sequence. Main sequence kind of runs, y'all know, this is like the main sequence, right? Kind of across the board, main sequence. And then you had those supergiants. And then the giants. And then somewhere in here you had the white dwarfs. Very dim. All right. So that's kind of a makeshift HR diagram. As far as the electromagnetic spectrum goes, here are a couple things that you will be required to know. Let's see. So one thing you probably want to know is those, since you have your node, I mean, it's not going to be that big of a deal, but you need to know the wavelengths in order from, I like to go from least to greatest. So we're going to go to the least energy, but that is the longest wavelength. To the greatest energy, which has the shortest wavelength. All right, so we are going to start. We're going to list them in order. We're going from least to greatest. And we're going to start with the very first one, which is radio waves. Then we have next up microwaves. After microwaves, we have that heat we feel, infrared rays or waves, either way. And then after that, we have visible light. Remember, visible light is made up of the rainbow of colors, and we remember that using an acronym, and the acronym is Roy G. Biff. So red, orange, yellow, green, blue, indigo. I wonder if I have a purple. And violet. Violet. That's all I have to do. No, that's too close to indigo. Let's make this violet. Oh, that's too close too. Well, there you go. I can't come up with a violet, but y'all know what it is, right? Roy G. Biff. So that's how we remember the colors. All right, after visible light, we have something we do not feel as heat and do not see as light, but we experience when we get tan or burned outside, sunburn, which is ultraviolet rays or waves. These are only felt under certain circumstances, but you are exposed to them every time you go out. Are necessary for that vitamin D production. And then we have X-rays and gamma rays. So all of these, beginning with ultraviolet light, are harmful to us when we're overexposed anyway. If you are asked about a frequency in hertz, these are the least frequent because they have the longest waves. And these are the most frequent, or the highest frequency. Highest is what you're supposed to say. Highest frequency. And if you are asked about frequency, that is measured in hertz. That's what it's measured in. If you are told that something has a frequency that corresponds to any of these numbers, then find the frequency number and compare it to where it is on the spectrum, and that will give you what type of wavelength was used. It's probably going to ask you about a telescope, so you'll just have to figure out what they used. It's not hard to figure out, and if you have questions, please ask your instructor. All right, so being that we've done this, we're going to do one more thing, actually. We're going to finish this up. We're going to add, what were we going to add? Oh, a couple little tidbits about seasons real quick. So the axial tilt is the reason for the season. Southern hemisphere always has the opposite season. So if the northern hemisphere, let me do this real quick. So if we have, and the seasons in order, by the way, are winter, spring, summer, and fall. And if we here in the northern hemisphere are having our winter, then the southern hemisphere is having their summer. That's for the southern hemisphere. If we are having spring, they are having fall. We are having summer, they are having winter. If we are having fall, they are having spring. Alright? Everything else should really be talked about on the seasons diagram, and since you do that during your testing, you should be good to go. And I think other than some of the things that will be on the test that we have not yet taught, that is it. We will give you the answers of items that we haven't taught you yet, just so that you guys can have access to that and not be penalized for not having gotten to that material. This was helpful. Good luck on your exam, and have a great day.